Let's see how to code the tic-tac-toe program. First of all, I started by reading the input. Then I am creating the grid. Remember the issue that we discussed when creating a 2D grid. You shouldn't try to like multiply something like empty string times n, because all of them will be shared in the memory. So the way to go is a for loop for n steps, and then for every steps I created a simple empty list with an n. So I choose here my representation to be just a pure string representation, where every cell is just either empty string or x and o. For simplicity, I created a simple string that is x and o, such that if the turn is 0, I can extract the x easily. If the turn is 1, I can extract the 1 easily. And then we keep going in the while loop here. Keep playing the game. If you thought about it, if you have a grid that is n times n, then if the users really reached that they did n times n step, then this means the whole grid is now complete. So it means we are in a tie case. So let's break here. Otherwise, then some player need to play. I'm having here a turn variable. The turn is initially 0, so symbols of 0 is x. And then I'm here switching the turn from 1 minus turn. If you observe it, if turn is 0, 1 minus 0 will be 1. If turn is 1, 1 minus 1 is 0. So it's a simple trick to switch it from 0 to 1. Now the user is playing a 1 based position. I'm converting it to 0 based position, and then verifying the location. First, I'm verifying that the R is within the grid, then verifying the C is within the grid. So I'm saying if not this condition or not this condition. Otherwise, finally, I'm checking the board that R and C, and observe that with the shortcut circuit evaluation, we know that if we reach to this condition, then R and C must be valid. If R or C are invalid, then we don't reach this condition. Without that, if the Python doesn't have the shortcut, the short circuit evaluation, then this condition would fail because it's going to evaluate this one. So this is a good about the short circuit evaluation. Finally, we started to put the board location here, like if player X will put X, player Y, player Y. After that, I am merging all of the grid together. For every row, I am joining them with an R, with an OR symbol, and then joining all of them with \n. This way, I converted the whole grid to an output in an easy way. Now, the final part is we need to check the winner of the grid. To do that, I developed a function called findWinner that will return either 0 or 1 or return none. Okay, to avoid duplicating code, I made an if condition here with wireless operator to get the result and assign it in winner. Then it's checking if it's in none or not. After that, I print who is the winner. And I observe that there is a parenthesis here. If you didn't put the parenthesis, what will happen is the condition would be like find winner is in none, then this all would be true or false, so winner would be assigned true or false. So always with wireless operator, think about the precedence. Now let's go to the winner operator. I click the control to jump to the function. We can definitely go and write very lengthy code to verify the board. Verifying the board is easy. You need to verify every row, every column, and the two diagonals. So overall, we have two n verifications. Every verification for them goes n steps. If you thought about it, all of the verifications have the same style. We start from some starting point like 0 and 0, and then we keep going for n steps to verify something. Like you start from 0, 0, n steps to verify the row, n steps to verify the column, n steps to verify the diagonal, and in every step you just shift your row and column, current row and column with some constant factor. So the moral of my idea was as following: I will develop a simple list that contains 2n+2 verifications that we need here, and I will just assign in every one of them two things. In every verification, 4 values. The first value is the R and C, which is the starting point, and then 2 values of the increment that we do. For example, let's say we are at 0 and 0. Then we need to verify the row. To verify the row starting from 0, 0, you need to keep going, incrementing the row with 1 and column with 0, and so on for n steps. If you would like to verify a column, you need to increment the row with 0, but increment the column with 1. So this is verifying the whole column. The diagonal would be 1 and 1, and so on. For the left diagonal, you start from 0 and 0 and keep doing 1, 1. But for the right diagonal, you start from the last element in the first row, and you keep going 1 row down and go 1 column back, and so on. So to do that, all I did here is I created my list. I started the list with a list that add every row. So the first row is 0, 0, the second row is 1, 0, 2, 0, 3, 0, 4, 0, and so on. For every row of them, the increment will be 0 and 1, the increment of the direction. And in a very similar way, I added the n column, so 0, 0, 0, 1, 0, 2, and so on. And then we have two diagonals, one starting at 0, 0, moving with 1 and 1, and one starting at 0, n minus 1, and moving with 1 minus 1. If you are done with that, we just iterate over every starting point, R and C, and direction row and direction C. We get the current player here. If this player is empty, then definitely this cell doesn't represent any winner. Otherwise, we know that this is, if all of the column or the row or diagonal is the same as this character, then we are winning. So I'm looping here the n steps to verify if any of them is, if all of them is the same player or not. If it happened, then this is when will never be changed here. So we know that this is a winner at the moment. Otherwise, we keep going here. We keep it changing our R and C to R plus the R and C plus the C. That's all. I hope that you find you understand the find the winner, and you appreciate why something like the position neighbors making our life much easier than a long ugly code. That's all.